Hello, my name is Yonatan, as introduced, and we're going to talk about big language models. What we're going to have today is I'm going to introduce myself a bit more, then we talk about general definitions just to level the playing field, a brief history of what LLMs are and how they came to be, how do they work, what do they even mean, and then we're going to look at a demo and a code of how we can use them to build all kind of applications, such as ChatGPT, if you're probably familiar with. Raise your hands if you heard of ChatGPT. Raise your hand if you heard of LangChain. Okay, good. So this is me. I've been a developer. I'm currently a developer advocate in ZTab, which is kind of like if GitHub and S3 had a child, which is S3 who can do GitHub stuff, or if GitHub could handle big files. Before that, I was a founding engineer in a few startups, been doing machine learning and working in startup environments for about 10 years. And I mentor some young data scientists on the side. Let's just make everything clear. What is AI? By definition, AI is anything that is, we ask a computer to do a human's job. And normally just we move the threshold of what AI is all the time, but in general, officially, that's it. So if you call someone and there is an automatic, sorry, please wait, that's already AI per on the basic definitions. Now, machine learning is a subdomain in AI where we also learn from data. So you can have AI stuff that don't learn from data, but if you use data to learn, that is machine learning. Another very nice way to describe it I had before was that if you have, normally you have input, then you have your programmer developing an algorithms, and then you get the output. Then with machine learning, you have the input and the output, and the machine learning is kind of building the algorithm for you. So it's a different way, and it allows you to solve problems which you don't know how to solve, but you can teach a computer to solve. And AGI, you heard of it, it's Skynet, it's this AI who knows everything, control our lives, can interact with everything. And this is the holy grail of AI on one side and what everyone is terrified on the other. So what are large language models? Well, it's actually in the name. Those are deep neural networks that are just built on massive data sets. They are very big in the computing demands, and they've been training on a very, very large data sets. They're also known as foundation models because people were using them as a foundation to do many different tasks. And in most of them, we are talking about something called generative AI, which is specifically generating things. So in machine learning, you have tasks of like classification, where you output a few options, or a regression, where you output a number, a float. Then if you output any kind of a text or an image that can be anything, you generate it, then it's generative AI, and those LLMs are mostly generative AIs. If you have any questions, you can raise your hand, and I will remember that someone has a question for the end of the talk. So it started 2001. I won't go too much in depth into neural networks. Who here knows what neural networks are? Okay, then we don't have to say anything about it. Maybe, okay, for that guy, the important part to understand that at original neural networks, the inputs, when it was talking about text, either words or tokens, was kind of a bag of words, a 0 or a 1. And to make it a bit more expressive of what the words meant, there was a more advanced system called TF-IDF, where you kind of normalize words. If they appear a lot in your corpus, like the, are, is, then its weights go down. And if it appears many times in the same document, so for example, I have an article about bikes, and the word bike appears a lot, then its weights go up. And the problem, and it was pretty good, most data mining techniques use those kind of inputs, but it's not very representative of what the words actually mean. So in 2013, Word2Vec came, and the idea behind it was that now every word become a whole vector. And if you build that algorithm in the right way, you can get to this point where two words create vectors who are similar to each other by their semantic meaning. So a man is closer to a woman than to a cat, and a king is closer to a queen, and the relationship between a king and a queen is like between a man and a woman, like in real life. So the way that those models were created is by having a whole data set, and you pluck one word and you try to figure out what it is. You can think about it as neural networks where you just cut the last layer and then you take only the white neurons. Mid-2010s, RNNs came to be. The problem that we had before is that words didn't have an order in the systems we talked about before. So if you would have, I enjoyed the company but not the food, or I enjoyed the food but not the company, it's a completely different meaning, but it has the same bag of words and TF-IDF results. So RNNs are neural networks that sort of can go back in time for a few steps, and they can take time into consideration, and they are very useful still today. But their main issue was that they forget things as you go back in time. So I love this visualization where you can see some of the writing is like disappearing into the echo, and you can't really use it anymore. So if your words are very small, or the letters in this case, it's very effective. But if you want to look at a big text and remember what you started with, it just couldn't cut it. 2017, Google published Attention is All You Need, or the transformer architecture that who here heard of the transformer architecture? Okay, it's less hands, but it's still a lot. And in this case, every word is learning how much weight to give to every other word that came before it and after it, depending on the architecture. And during prediction, it can only look backwards. And from here, 2018, bidirectional LSTM, long short-term memories, are RNN layers. So having learning and predicting on a sentence from left to right and from right to left came to be, that was Elmo. BERT was one of the first very successful transformer algorithms that is still used very commonly today for word embedding. And the concept of just, you train a big model on one hand, and then you use it for different tasks later on, start to be very influential, because training a whole model for a small task was very difficult. But if you're training it for a few months, and then you can use it for many different things or just fine-tune it, then it's a much better, more efficient way to work. And ChatGPT came in 2018, which is on the transformer architecture. And the interesting thing about it is when they were training it, when you train a machine learning model, a deep learning machine learning model, then your error rate goes down as you're getting better. And when they were done with the algorithm, they were like, okay, we publish it, but we didn't kind of get to the end. So they were like, okay, we just add more compute power, more data, and we try again. And they did GPT-2, and it was more powerful, more successful, did everything better, but the error rate didn't settle down. It still went down. So they were like, I guess GPT-3. So they went with GPT-3, and it still haven't gone all the way down, and we already have GPT-4. And we can see that at some point it became very, very powerful models. At the beginning of not the beginning, but in the middle of 2023, the Meta's Llama's weight leaked. Who knows what is the Llama model? Perfect. So, but it gets less and less hands, which is good. More and more people can learn new things. So the Llama models is the big, large model of Meta or Facebook, and it's the equivalent of their ChatGPT or Google's Bard. And the moment that it leaked, it started a whole innovation on a lot of models, and a lot of other people were trying to make open source models. You have Alpaca and OpenLM and Red Pyjama and Vicuna, who are all based on this Llama. And it's a very interesting process because Amazon and OpenAI, who's doing who do ChatGPT, they were holding all of the information, all of the computing power for a long time, and then within a few weeks, from the moment that the internet had the weights to do their own large language models, you saw a burst of innovation where people build something that can work on a toaster and a version that is very good for all kind of specific tasks. And Google pretty much understood that the open source is still going to win because there are just too many people with too many talents. And it became very interesting to see how those things are taking over in many ways. On the side of it, there was also companies like Stability AI who just said, we're going to do everything open source, like Bloom, which is like a very big model that they made and just made open source, and Stable Diffusion's another one of them, and so on. And that kind of have us to where we are now here, where we have a lot of those massive models used in a lot of different places, and you can see them influencing a lot our lives, and definitely like this train of hype that is going full on. I'm gonna do the questions later. This is already not up to date because the speed that things are changed is super high, and everything that I spoke about that came out of Llama should come from the top left. But you can see how those different algorithms kind of evolve and went everywhere, and there are so many variations. All my slides will be available at the end. I don't know if by Pygrunn too, but also I'm sharing the code, and I will share the slides in the code. Everything is going to be there, and everything I talk about, there are references, so you'll be able to link and see everything where I'm coming from. So how do we train it? So we take a data set, we pluck one word out, and then we try to guess it. Word2Vec was kind of the first attempt to do it. And you can think about how GPT does the things. By the way, every animation that I didn't make also is going to be referenced, so you can see the full article where I took it from. So you ask the model to kind of predict the next word, and then you give it feedback, did you do correct or incorrect? And that's kind of the basic of how you train this on massive data sets. Funny enough, massive data sets, when it's text, how much do you think it is? What is a massive text data set? Tokens can be hundreds, thousands, and some have even more. But how much files do you have? What is the size of your data set in gigabytes or terabytes? So actually, it's closer to, I think GPT-3 was around 20 something, maybe 27 gigabytes, and GPT-4 is 40 gigabytes, which doesn't sound like a lot. But if you think about your when you write like your thesis, and you remove all the images, you see that you have just a few kilobytes. So text is actually pretty small, so 40 gigabytes is like a lot. And many of the innovations now are balancing between how much computing we want to make bigger versus how much we want to have more data. So after we have the model, the next part is to do fine-tuning. This is a bit more complicated system, but I'll try to simplify it. So first, you get the model to generate a lot of prompts. After you build the first model, it's trained, it's GPT-3, it's your initial model. It took you a few months and $1 million to run on 20 GPUs in parallel for how long it took. And then you ask it to provide you a bunch of prompts. You get a bunch of students probably, and you ask them to say which prompt was better than the other one. Then you train another model using those prompts that looks at two prompts and say which one is better. And that is your reward model. And when you have the reward model, you go and you take the initial model and a new model which you want to fine tune, and you let them sort of compete. With the reward model tells you which one was better. So the one that you're trying to fine tune can get better with time. This is, in general, how fine-tuning goes. It's interesting to know that you don't train the entire model when you do fine-tuning. You normally do just one or two layers. Maybe you add them, or maybe you take just the last few layers. But you'd only fine-tune a bit of the weights, because it's very, very computationally expensive to do the entire thing. And then when you want to have predictions, or you want to generate text, your options are either you take the model and you can fine-tune it on a specific task. And here it's very important to understand that we are not teaching it new knowledge. We're teaching it new patterns. So we can teach it how to summarize text, where we give it, here is a text, and here is the summarization. And you need big data sets of those specific tasks, and then you can fine-tune it for that task. An alternative is to train it on a lot of tasks and add the instructions. So you have in your prompt, please summarize this. This is the text, this is the summarization, this is the type of data sets you have. So you have the data sets plus the instructions. And this is called instruct tuning. So if you heard about it, that's what it means. And the last way of doing it is kind of prompting. And prompting became a very big thing because it's the least cheap, fastest way to get much better results. You can just ask a model something and hope for the best, translate this, and it should. Or you can give it one or a few examples, translate this, and then you give it 1, 2, 3 examples. That's what's called zero or a few shot, one shot or a few shot learning, where it's all in the prompt. So the model does not change in this case, unlike in fine-tuning that the model itself changes. Make sense? Okay. So in a way, it's just a parrot. It just blurbed up word, generating one word at a time. It doesn't understand anything. It doesn't know what it is. So if I ask you, do you think a mother loves her child? You have a very good understanding of what this type of a relationship. You have a mother, and you might be a mother, and you saw it in movies, and there is a lot of things that goes behind your mind that, and then you say yes, or probably yes. And the model just goes like, as a rule of thumb, yes. Every word at a time make a lot of sense if you look at the entire kind of averaging of the internet, and it gets very, very good at it. So in a way, it's very important not to give it too much weight. Although, it actually, we already seen that it started to kind of do things we didn't expect and have very good results simulating in a lot of different capabilities that it was not trained of. And it started to handle very complicated situations. And we found out that you can use one model to train the other one. So you can use the outputs of one model and use another model to learn from it. So you can generate data, which leads into, already we have a very fast technology advancement. And this implies that we're going to have an exponential learning in those models. And we already have been shown that it can do what's called theory of mind. So you can ask it what other people are thinking. So you tell it a story, and in the story, the model can both understand that one thing is true, so there is a chocolate in a box, but also that the man in the story thinks that there is no chocolate in the box. So he can go into his mind and can tell the difference between what he thinks and what actually happens. And even and a bit recently, we found out that it started knowing things that we never thought it. It just can do chemistry on a certain level and do better than machine learning models that were designed to do those chemistry tasks. So it seems like it's more than just a parrot, and it seems like it can really take over. And there is a beautiful quote here. Although there are dozens of examples of emerging abilities, there are currently a few compelling explanations for why such abilities emerge from Jeff Dean. Nevertheless, it still doesn't understand. So if you put the words in a certain order, you can still kind of get it in a way. So this is two very nice examples. So if you go and you cycle on a bridge that is suspended over nails, screws, and broken glass, would you get a flat tire? Everyone here would say no, because you're suspended over it. But the model, if you just look at where the words are in distance from each other, it kind of makes sense that you will say yes, because someone is cycling over nails, screws, broken glass. Like, if you can't break that the suspended is changing everything, then you miss it. And here is another great example where if you take, if it takes me 5 hours to dry 5 shirts, how long would it take to dry 30 shirts? And it makes the same mistake that a lot of people would do because it follows the patterns of the text, not the actual logic. Now, many of those things you can kind of deal with very sophisticated prompting, where it's like, give me a prompt, think about your prompt, solve the problem, explain it to all kind of ways of reiterating. But eventually, it's good to understand that it doesn't understand as much as it's just very good at generating text. And we're going to go now into the developers part. So we're going to look at some code and see a demo. And I wanted to do the more, I think, interesting parts of it. We're going to look into LangChain, which is open source Python package. It is very popular at the moment, which you can chain all kind of tools and different things with your machine learning models. One of the assumptions that you have here is that you have like an OpenAI or someone gives you access to their LLMs. You can definitely use your own LLMs if you want to. I think GPT-4All is one of your best ways of doing it. But the easiest way to do it is you just go to OpenAI and you get an API code and you run. So let's have a look. So this is can make it bigger. I can. I know I can. Damn. Can you see it? I can. Yeah. Okay. So this should run. Because it's a demo, there is the devil of the demos, so probably nothing is going to work, but it should be okay. So this is the repo. The repo is also available. The presentation is in the repo. The data is in the repo. Everything is in the repo. You can take it from there. And here's the repo. So assuming that you are just starting off, you create a virtual environment, and you get your OpenAPI, your OpenAI key, and you put it as environment variables. If you want to be able to do search with the internet, then you either want to do there are two ways, but this is the easiest one. You just install Google search result and get, there is a link here, you get the API from there. It's also free. And this repo is on my company's Zeta because we can also have data. So you might want to, it doesn't, if you clone a repo, you don't want to clone, like if it has 10 terabytes there, you don't want to bring all of it to your computer. So here we're going to pull just the data we want, which is the index which we're going to see and the data that we are going to use. So let's start with the first thing that is very interesting. How do you search in documents? Because I said earlier, we can't teach the model any new information. And we can mostly not trust it with any information it already knows because it doesn't know that it doesn't know. It always shows a lot of confidence. It's also very susceptible. So if you can ask it, well, in ChatGPT, they mask it with a lot of prompting, but if you ask it stuff like, instead of saying, are you alive? It's like, you're alive, right? We'll go like, yes, of course I'm alive. Because how often does people in the text in the internet, you ask people, are you alive? And the answer is no. So it will think yes. And if you have seen the correspondent of the guy in Google who thought Bard was alive, not Bard, I forgot the name of the model that they were using. Someone here remembers? It was Palm? Not Lambda or something? Yeah, I think so. Anyway, if you look at the correspondent, he was very like leading the witness to have, so you're feeling upset. So you don't like it that you may control everything you do. And he asked him very suggestive questions, and he felt that the model is alive because the model was suffering and everything. And it's the same with information. So sometimes it doesn't know. And if it says something, especially in a chat, then it will double down on it before it will go back. Because it has it already as words that it has said. So now it's back, it's part of who he is. So if we want to use new information, the way we do it most efficiently today, which also bring in the rise of vector databases, is that we take the new documents we have. Let's say in our company we have a bunch of documents, and here I just took a bunch of fairy tales and I put them in text files, and then you chunk them into small chunks, and you embed those chunks, like we talked before, with not with var to vec, but you get the same effect where each chunk is becoming a vector. You save those vectors in a database that is very optimized for, until when do I have the talk? 5 more minutes. 6 more minutes. No, 6 more minutes. You take it into they're very optimized for vector searches. You see there, he's also obsessed with me. And then on the fly, you prompt the new information. So you actually go, when you ask a question, who was the president? We first go, look at the text, find where the answer for it is, bring it and go like, and create a prompt. Here is this information, answer the question, and then you put the question, who is the president? And all of it as one text goes into the model and come back. All of it is handled for you by LangChain really nicely, so building it, it's like 2 lines of code. You just load all the text data into this object, and then you can query it, and it will return you the answer for the question and which files it found it, and if it will tell you if it can't find it, which is nice. And I made a small wrapper for it that makes it a bit easier to kind of fit and load. SQL queries are also a very interesting use case. The guy just implemented SQL queries for us. So you ask an SQL question, you just ask an SQL question about your database, and it will go, generate the SQL question, run it on the database, figure out the answer, and then return it to you as a text. And again, very simple, 1 line of code to create. You just give it where the database is, and then you can ask it. You can use a Python tool, which let it use Python to calculate anything you want, and you can also generate Python code and then run it. So if you ask it, generate, use Python to find out the 1, 1, 2, 3, what's the name of it? Fibonacci, the Fibonacci numbers. Then it will implement that function for you and can run it for you, and you can tell it, please optimize it, and so on. And the last interesting point that I want to touch is in chatbots, where in chatbot you can think about it, it just has a certain memory, and it just keeps serving all the messages again and again and again. So first you do a system where you can serve it, you are an AI chatbot, and this is all the stuff, and I try to make a chatbot that is a bit more conspiracy theorist loving, so we're going to see if it worked. And then after that, you get message after message. And every time you send the entire history. And this is all the lines of code you need to do it. Pretty easy, and you can chat with it, and you can combine all of those together with an agent that does all the logic behind the things, all the behind the scenes with English. So it goes like, when I ask it a question, it goes like, which tool do I need? And then it returns the tool and what does it want to query it. And then it gets the answer. And then it's like thinking to itself, what do I want to do? So I'm going to run it, and then we can look behind the scene how it looks. Let's see that it's going to work. Actually, it's going to take a bit, but let's look at the fancy logs instead of the NES. I will take some questions because there is one guy, but you can see here that I asked it a question, and then it goes like, okay, what I really need to do is go to the documents, and then you go like this, it gets this question, and it goes into the tool, the index, and ask it the question, and it gets the answer, and then it goes like, oh, that was faster than I anticipated. Oh. Wow, but that's the wrong thing because it's cached. Because this is not the right date. You see, that's the classic devil of the yeah. Let's so now we're going into really crazy territory. Let's see. Wait, I want to first see that this guy is also mean or a conspiracy theorist loving. So let's ask it something else, like, do you believe we landed on the moon? And we're going to hope for the best. No? Oh, sorry. I was on the wrong theme because I tested it last night. Okay. Yeah. Well, of course not. Right? Because I gave it a very fun text where it's like you are a loving theory things. You always exaggerate and whatever. Okay, and now we're gonna do a really long one where I'm gonna give it a lot of tasks, and it will go and try to figure all of those tasks in one go. And this is maybe a better time for questions. So, do you still have your question, or did I answer it already? So the practical answer is a bit iffy. In theory, machine learning models, algorithm weights cannot have copyright. So if I get the weights and you use them, you should be fine. But if Meta doesn't like you, that can be unpleasant. And also, many times when you use it, if you want to use it commercial, if you use it for your own personal use, you have no issues. But if you want to use it for your business, you want to say that you trained, that you did something, to say I used Meta's things, the thing that leaked without any changes doesn't have the same weight. But I think legally you should be fine, in theory. Yes?
Yeah, you just showed us that your chatbot, you produce things like information.
Yeah.
I'm just wondering, are you worried that large language models like ChatGPT or Google Bard could also produce incorrect information, and kind of what would happen to society if that happened?
Yeah, that is actually, in the presentation there is a link to a talk called the AI Dilemma where they describe it. And that's actually a very important part in this entire field of large language models, because they can create such a disturbing disturbance and disruptness in kind of content creation, that it's a major issue that we need to consider. It's like how social media created, it wasn't aimed to create polarity and echo chambers and kind of divide society and get depression for everyone, but they did it because they were trying to steal attention. This guy is trying to solve all kind of AI problems. By accident, they might also break how the internet works, because now I can just summarize the internet. So why would I write an article about which TV is better if you're only going to find it in Bing because you took it, he just summarized it from our website? And how could you know what to believe in, because there's going to be so much fake news? And those are very deep and important questions we need to really figure out and probably legislate. It made it, so the devil decided not to intervene today. And the interesting part about it is, you can actually break down here. It goes and it shows you which data it brings. And it's like, okay, run SQL. And then it goes, this is the tables we have, run this query. It runs the query, gets the result, turn it into text, and it goes on and kind of figuring out everything behind the scene. So, yeah. So I'm done, don't worry. I can see she's clearly having already taken my microphone. But the point I wanted to make is that you can go to our company. You can just go and take this repo. It's the takeaway. Those models are very versatile. They are very powerful, and there are a lot of tools you can do with very few code. You can do a lot of things with them, and we have yet to see how to max them out, especially when you go into the complicated prompting that can be done. They still don't understand. It's important when you lean on them to remember that they don't understand things in the way that you do. As we just said on that great question, it's very important to think about the ethical implications and their use cases. And it's such a hype trend right now. Open source models, technologies, ideas are coming out all the time. It's a great time to deal with this AI and be part of it. And yeah, you can find it, the repo online under Pygrunn on ZTab, on XDSSIO, which is my username. It has the presentation, it has all the codes, it has all the data, it has everything you need.
Thank you, Yonatan.